In this video, I'm going to try to explain how insert after method works. In this case, we have three uh, segments of code, three portions of algorithm. We have if, we have else if, and we have else. And we're going to try to execute three commands. This one, and this one right here. What we want to do is to execute this method first, which contains three parameters: the list name, the location where we're trying to insert after which node, and the actual node we're trying to insert with the value, data value type integer with a value of 9. In the second case, list name, the node or location in the list where we're trying to insert which node we're trying to insert the node after, and the actual node with a value. And same thing here, list name, where after which one, which after node 9 with a value 9. In this case, we're inserting node 4. The values have no sequential meaning for this method insert after. So technically, we cannot just say, oh, 9 is like it's bigger or 4 is smaller, therefore the location, like the sequence, 9 may be at the end of the list in the tail, and the 4 could be also could be in the tail, and vice versa. So let's see how it happens. We have an empty list. Executing first line. The null is assigned to the current node. Executing second line, assigning the head to the new node. Assigning the tail to the new node. And it's executing and skipping the rest of the code because the list was empty, just like in the previous videos. And let's see what happens next. So now the list is not empty. So it's going to check if the list is empty or not. So it goes to the second portion, assigns the tail and a next pointer to the new node. And I think it's going to place it after the existing node with the data value 9. And data value 9 node remains as the current node, and the tail is not assigned yet. Neither the next and previous pointers with a new node are not assigned yet, which previous node is going to be assigned in the next line. Here you go. New node equals previous list tail. Because tail is not assigned yet. And here we're assigning the tail now. We're changing the tail to the new node because it's at the end of the list. And it's skipping the other one because now we have two nodes. Let's see what happens next. Now we're going to insert after node with a value 4. The first skips all the way to the end, to the else statement, assigns the next pointer of the new Well, now this one becomes the successor node, and that one, the head, it still remains as a current node. The new node is inserted after location with the data value 9 node and assigned next pointer of the new node to the existing successor node, uh, which is with a data value of 15. Let's see what happens next. So the new node, previous pointer, assigns to the current node. Right there. And the next line of code executed, the next pointer assigns to the new node from the current node. Interesting. And what happens next is the successor node, previous pointer, assigns to the, and finally places the new node after node with the data value of 9 and in front of the node with the data value of 15.